First, a quick tour of the features of this fan. At the bottom are the buttons to set the fan speed, a dial to adjust the pitch of the fan, and then the pin on top to make the fan move back and forth. You know the drill by now. Your fan might be slightly different, but the mechanisms I'm about to show you are probably very similar. Unless it's a box fan, or one of those tower fans, or a bladeless fan. These are pretty cool. I might have to do a future video on this. But for now, let's focus on this fan over here. Taking one apart is pretty simple. Several screws in the bottom, and plastic pieces to take off. The coolest parts are at the top. Sit back and relax, and we'll let the 3D animation do all the hard work. Okay, let's start at the bottom and go through this in detail now. 4 buttons, 3 speeds, and then the white one turns off the fan. Each time you press down a button, the previous ones are released. The white button turns the fan off. It also doesn't stay down like the other buttons do. If you've been following my YouTube channel, you know that I like to explore different mechanisms. And there is definitely a mechanism here. Let's take a look. Each button has a spring underneath that wants to push the button back up. Inside is a metal plate with a few jagged cuts going down. This metal plate is being pushed to the right by this spring. By pushing down a button, the plate slides to the left. Push down far enough and it clicks into place, preventing the button from coming back up. Press down another button and the plate slides enough to release the first button. The sole reason for the white button is to release any of the other buttons. You'll notice that there's no notch to hold the white button down. Releasing the other buttons will then turn off the fan. Coming out the back here is 3 color-coded wires. Whichever button is pressed will send a signal up the wire to the top of the fan into the motor to start the fan spinning at whatever speed we choose. At first, the fan will only be pointed in one direction. But if we want to cool off more of the room, then press the pin and the fan starts oscillating, or in other words, moving back and forth. We already have an electric motor, and we don't want to add another one. The idea here is to convert the spinning motion of the fan into a side-to-side motion. Let's take a step back so we can understand the concepts behind this. This is called a 4-bar mechanism. Each bar is connected by pins which allow them to rotate freely. One of the bars is usually fixed in place so that it can't move. This one is called the crank. Usually a motor is causing it to rotate around. These other 2 bars are forced to follow the motion. By changing the lengths of these bars, we can get some different motions. Let's focus in on this configuration. Normally, the green bar is the one that's fixed in place. Watch what happens when instead, the small blue bar is fixed in place. Now watch the motion of the green bar. Notice how it goes back and forth about the same amount. This is how we get that oscillating motion for the fan. Now let's go back and see how all of this works on the fan. So the 4 bars on the fan are right here. This is the short bar that's fixed in place. There's a long bar here, and another long bar, which in this case is the motor. And then the last bar, which is the crank. This is the one that has to rotate to get the fan to start oscillating. But there's still a missing piece. How do you convert the rotation of the fan